What's up, guys? It is Monday, March 30th. We are almost done with the month of March. So close. So today we're going to be talking about asexual versus sexual reproduction, and really my focus is going to be on sexual. My focus is going to be on asexual reproduction. Tomorrow we're going to talk a little bit more about the process of making the sex cells for sexual reproduction, but there's not a lot on sexual reproduction on the regions, so we'll curtail it to asexual and the process of making the gametes. Alright, so asexual reproduction. We are going to jot a few things down here, and the way I like to do it is like this. We'll have asexual reproduction versus sexual reproduction. Okay? And then I make a little T-chart like that. So, asexual reproduction. You start off with one parent cell. I like to say cell, right? Because it's not like a person is going to be able to just, boom, make a baby without another partner. It doesn't work that way, all right? So it's one parent cell. With sexual, on the other hand, there are two parents, right? In asexual reproduction, how does the offspring look? Or how is it genetically? It should be identical to the parent, right? Genetically identical to the parent cell. So it's genetically identical. On the other hand, with sexual reproduction, it is not genetically identical. Genetically different from parents. Right? So there are pros and cons in all of this. With asexual reproduction, what is the pro? In other words, what is the benefit? The benefit is you can make lots of offspring so that your species can continue. Many offspring can be produced, right? The pros of sexual reproduction, you get something called genetic variety. We can look at this just with the COVID-19 virus, right? You have people that they're saying that get the COVID-19 but experience absolutely no symptoms in the world. And then you have others that get very sick from it. And genetics right there, right? Some people will be able to fight that. Some people can't. Some people are prone to different problems with their lungs. Other people's are not. Other people are not. Other people are not. So genetic variety is a good thing, especially for the long term in a species. The cons, on the other hand, if the offspring in asexual reproduction are identical, if there is a problem, if there is, say, a virus that comes through and is going to wipe out one of them, if they're all identical, then they're all prone to being wiped out, right? So genetic diversity is a great thing. If there is no genetic diversity, then the one thing that can kill one can kill all. So a virus that could harm one organism will harm all of them. So that's the con. The cons for sexual reproduction, well, if you think about pandas, they have to find a mate. They have to mate. So it's the con here is finding a mate, and then of course raising that offspring. Alright, so what are some examples we'll do of asexual reproduction? We'll start off with the human world over here, and we'll talk about mitosis, which I'll draw for you tomorrow. But mitosis is just asexual reproduction. I'll give you a quick example. You have one cell, That's the parent. And then that is going to lead to 2 genetically identical cells. When does this happen? This happens all the time. It's happening right now. You have skin cells that are growing. So skin cells. What else can there be? We have immune cells, right? Blood cells. And then, of course, there are other types of cells, cancer cells. So those are some examples of mitosis. And the definition of a cancer cell is a rapidly growing cell that is non-functional. So that's mitosis, and that happens in humans. Now, there are some other things like mitosis. There's something called fission. Same as mitosis. The difference is it's in bacteria. So we'll say mitosis in bacteria. So that was the second example, and I'll put little underlines on these. We'll use a different color. We might as well, right? We'll get crazy. Woo! Okay. Next one. I have these in order here, so I just don't want to screw up. Budding. There's a spider on me. This is what happens when you're outside. I did my best not to freak out. Alright. Budding. Budding is basically, I'll show you what it is actually. It works out better that way, right? So if we look over here, we have a bud. You have a hydra. And if you look at the little hydra on with number 1, you see the little bud to the bottom right. And then you have it growing off at number 2, and number 3 it gets bigger, and number 4, boop, you got like a nice, I don't know, another hydra, right? So that's budding there. And this happens in hydra and yeast cells. Hydra and yeast cells. And it's defined as it's the unequal distribution of cytoplasm in asexual reproduction. And if I was to enjoy a little picture, here's a little hydra. And then we'll draw, there's a little bud coming off the hydra. And then we'll draw you see it? And then basically eventually it will be its own organism. I'll finish that for you. We'll use green. There's one. And then you have a little baby hydra. Oh, it's so cute. Alright, next one over here. I think we have sporulation, right? Yeah. Next we have sporulation. And in sporulation, it's basically what molds. They pop open and they release their spores. If you've ever eaten bread, sometimes the spores, if it's moldy, will release there. You can see that here. It's like poof. And those are all spores. That's a great little view there. So it's just the release of spores by by mold. The release of spores, typically in mold. Alright, next one over here is going to be regeneration. And this is going to happen in starfish. It happens in lizards. Deer's antlers can regrow. So it's the regrowth of a part of an organism. And that looks like this. You can take a look at this one to the left over here. This person is cutting off this poor starfish's leg there. Ray. And it's growing back. Whoop. There you go. That's regeneration. And then we have one last one. Why is this not here? There we go. And this is an example would be a starfish or a lizard. Last one, vegetative propagation. And this is using like a branch of a tree or a plant to regrow that plant, to regrow that tree. And it looks like this. Huh. So you're cutting the piece of the plant, and then you're putting that piece of the plant into soil, and then it can regrow. And again, these are all clones. They're identical to the original. So this is good if you want to make more of the organism. But if there's some sort of virus that comes around that wipes out that plant, it's going to wipe out the one that was regrown off of the branch because they're genetically identical. They have the same DNA. Come on. So using a branch of a plant to you put it in soil and grow a genetically identical plant. All right, so we have, and I'll leave that there for a second. All right, so we have asexual versus sexual. Asexual, you have one parent. They're genetically identical. Sexual reproduction, two parents. You have a sperm and an egg combined. They are genetically different from the parents. The pros of asexual, you have many offspring. Pros of sexual, there's a lot of variety. Cons of asexual, there's no variety. The cons of sexual, you got to find a mate, and you got to raise that offspring. These are some examples. We have mitosis in humans. You get cut. Mitosis is going to help that, fix that. Fission is in bacteria. Budding, that's hydra. Sporulation, that's in mold. Regeneration, starfish. And then vegetative propagation, that's growing trees. If you look like right behind me, that's actually a reflection of my neighbor's yard, and he has a bunch of trees there. So I could take a branch, put it in the ground, and grow it. All right, I'm going to have another one up. I'm going to go over a worksheet with you. And that's that. Have a nice Monday afternoon.